Imagine a place where the rules of reality simply break. A bottomless pit in the fabric of space so heavy that it forces light itself to bend, warp, and get trapped forever. You are looking at a black hole, the most extreme object in our universe. A black hole is not just a hole, it is a massive amount of matter packed into a tiny point. Its gravity is so intense that nothing, not even the fastest thing in existence, light, can escape its grasp once it gets too close. As cosmic dust and gas swirl toward the event horizon, they accelerate to near light speed, heating up until they glow brighter than entire galaxies. This creates a spectacular ring of fire around a dark, empty heart. But here is the strangest part. Because this object is so heavy, it actually curves the space around it like a bowling ball resting on a trampoline. This is called gravitational lensing. When light from distant stars passes by, it gets stretched and twisted into glowing arcs. It is nature's own magnifying glass, revealing the secrets. Most people look at the night sky and see cold, empty darkness. But they are missing the most violent fireworks show in the universe. Deep inside these dusty clouds, a battle for existence is happening right now. Imagine a cloud of gas so big it would take light years to cross. Yet, it is quietly falling apart. Gravity is the ultimate bully here. It grabs onto loose hydrogen atoms and pulls them toward the center, tighter and tighter. As these particles race inward, they start to crowd each other. It's like a massive stadium exit where everyone is pushing to get through one tiny door. The real problem is heat. As the cloud shrinks, the pressure builds. If the gravity isn't strong enough to squeeze the gas into a tiny, super hot ball, the whole thing just fizzles out into a cold, dark lump. It's a total race against time. Suddenly, the center hits millions of degrees. The atoms can't just sit there anymore, they start slamming into each other so hard they fuse. A star is born, lighting up the dust. What if I told you the ground beneath your feet exists only because of a violent, endless explosion happening millions of miles away? Stars might look like peaceful lanterns in the night sky, but that's just an illusion. Deep within a star's core, gravity acts like a giant cosmic vice. It squeezes hydrogen atoms together with such incredible force that they have nowhere to run. They are crushed until they fuse, transforming into helium. This process, called nuclear fusion, is the ultimate energy source. It's not just a small spark, it releases enough raw power to hold up the entire weight of a star. But here is the problem. Gravity wants to collapse the star into a tiny, dense point. The only thing stopping that total destruction is the constant outward push of energy generated by this fusion. It is a never-ending tug of war. For billions of years, the star fights this battle, glowing with the plasma born from its own destruction. If the fusion stops, the star dies. Every beam of sunlight hitting your face is the result. Imagine a bomb that never stops exploding, yet somehow stays perfectly still for billions of years. How does a star keep from collapsing under its own massive weight? A star is essentially a massive game of cosmic tug-of-war. On one side, you have gravity. It is a relentless giant, constantly trying to crush every ounce of the star toward its center. If gravity were the only force at play, every star would vanish into a tiny, dense point in seconds. But there is a hero in this story: nuclear fusion. Deep in the star's core, atoms are being smashed together with enough heat to power a galaxy. This creates an outward pressure, a massive blast of radiation pushing against the crushing weight of gravity. When these two forces reach a perfect stalemate, we call it hydrostatic equilibrium. The problem is that the fuel doesn't last forever. Once the star runs out of hydrogen to burn, the outward pressure drops. Gravity finally wins the fight, leading to a violent final collapse. Everything you see in the night sky is just a... Imagine a furnace the size of a solar system, burning with enough power to outshine entire galaxies. But deep inside a massive aging star, the clock is ticking toward a violent end. The star is built like a cosmic onion. On the outer layers, hydrogen fuses into helium. Deeper down, the heat rises, forging carbon, neon, and oxygen into heavy shells. Each layer burns faster than the last, desperate to keep the star from collapsing under its own crushing weight. It is a frantic race for survival. Then the star hits a wall. It begins creating iron. Unlike other elements, iron refuses to release energy when it fuses. It is a thief that steals the heat, keeping the star inflated. In a heartbeat, the outward pressure vanishes. Gravity wins. The core, once a stable furnace, becomes a ticking bomb of cold, dense metal. When that iron core grows too heavy, the entire structure collapses inward, triggering the most spectacular explosion in the universe. Click here to see what happens the second that iron core finally gives way. Imagine a star 20 times the size of our Sun running out of fuel. In a fraction of a second, the gravity that held it together for millions of years turns into its own executioner. For an eternity, the star fought to stay alive by burning fuel at its center. But once the iron core forms, the party is over. Without the outward pressure of fusion, the star's massive weight crushes its own heart. Of tons of plasma rushes toward the center at nearly a quarter of the speed of light. It is the most violent collapse in the universe. As the core shrinks into an impossibly dense ball, the outer layers slam into it and bounce off like a ball hitting a concrete wall. This creates a shockwave so powerful it tears the star apart from the inside out. This isn't just an explosion, it is the birth of a supernova. Elements like gold and silver are forged in this chaos, eventually scattering across the cosmos to build planets, and perhaps life itself. Click the video on your screen to Deep in the dark corners of space, a massive star is running out of fuel. It's been burning for millions of years, but suddenly, the core collapses in a fraction of a second. This isn't just a fireworks show, it's the most violent explosion in the universe. In one blink, a star becomes brighter than an entire galaxy, blinding everything in its path. You might wonder why we care about a dying star so far away. The truth is, without this chaos, you wouldn't exist. During this explosion, the heat is so intense that the star begins to cook up heavy elements like gold, silver, and iron. It blasts this material across the cosmos like a cosmic cannon. This debris eventually crashes into gas clouds, forming new planets and even the building blocks of life. Every atom in your body, from the calcium in your bones to the iron in your blood, was forged in the heart of an exploding star. We are literally made of the ashes of ancient supernovas. Click the next video. Imagine standing on the edge of a place where light itself goes to die. If you fell into a black hole, you would never be seen or heard from again. What you are seeing is the event horizon. It is not a solid surface, but a threshold where gravity becomes so intense that even the fastest thing in the universe, light, is trapped forever. Surrounding this dark abyss is the accretion disk, a swirling ocean of superheated gas and dust. It spins at speeds close to the speed of light, glowing with enough radiation to outshine entire galaxies. The real mystery begins with the background stars. They look stretched and warped because the black hole is acting like a giant invisible lens, bending space itself. This is called gravitational lensing. It is as if the universe is folding around the hole, distorting your view of reality. The challenge for scientists is that we cannot see what happens past the horizon. Once anything crosses that line, the laws of physics as we know them simply break down. We are peering into the greatest. Imagine a place where the rules of the universe simply stop working. What happens when everything you know, time, space, and gravity, is crushed into a single, infinitely small speck? Deep inside a black hole lies the Singularity. It is a region of impossible density where the fabric of space-time doesn't just bend, it snaps. Our current understanding of physics relies on math that works perfectly for planets and stars. But at the Singularity, those equations return a result of infinity. In science, that is just a polite way of saying we have no idea what is happening. The real challenge is that gravity follows Einstein's rules of large objects, but the tiny world inside a singularity follows the chaotic rules of quantum mechanics. They refuse to play nice together. If you look closely, you'd see reality folding in on itself like a twisted knot of geometry, where distance loses all meaning. Is this a doorway to another dimension, or just the end of the line for our physical laws? We are staring at a cosmic dead end, yet you are drifting through space, but you aren't floating toward a planet. You are falling toward a monster that eats light itself. A supermassive black hole is so heavy that it bends the fabric of space. As you get closer, everything behind you looks like a funhouse mirror. The stars stretch and warp, creating a glowing ring of light that surrounds the darkness. This is the event horizon, the edge where gravity becomes so strong that not even light can escape its grip. Here is the strange part. If I watched you fall from far away, I would see you slow down. You would look like you were frozen in time, eventually fading into a red blur. But for you, the clock keeps ticking. You would cross that threshold in seconds, pulled by a force so intense it stretches your body like a piece of string. Once you cross that line, there is no turning back. The laws of physics as we know them simply break down. You are now inside a place where space is falling. Imagine falling toward a black hole. You check your watch, but something feels wrong. To you, everything seems normal, but out in the universe, centuries are flashing by in the blink of an eye. You aren't just traveling through space, you are drifting through the fabric of time itself. Gravity is a powerhouse. It doesn't just pull on your body, it pulls on the ticking of your clock. Near a black hole, the gravity is so intense that space and time get stretched like a piece of rubber. As you get closer to the edge, the light from distant stars begins to race. They zip past you like streaks of paint because your perspective of now has completely detached from the rest of the galaxy. The real problem begins at the event horizon. This is the point of no return. If someone were watching you from a safe distance, they would see you slow down until you appeared to freeze in place. You would never actually cross over from their view. You would just fade into a ghostly red stillness. For you, however, the void just... Imagine standing in the silent void of space, watching the entire history of the cosmos unfold in the blink of an eye. What if you could see the universe not as a static painting, but as a living, breathing engine? When we look at the night sky, everything seems frozen. But in reality, the universe is a chaotic, high-speed collision of energy. From your vantage point, galaxies don't just sit there. They spin, collide, and dance in a cosmic ballet. You would see stars ignite like fireworks, burning through billions of years of fuel in mere seconds before collapsing into brilliant supernovas. It is a violent, breathtaking cycle of creation and destruction. However, there is a catch. As you watch, the space between these galaxies is stretching. Everything is moving away from you, and it's speeding up. We call this dark energy, a mysterious force pushing the universe apart at an impossible rate. We are racing toward a future where galaxies will eventually drift so far apart that they vanish from our sight entirely. The universe is... If you fell into a black hole, you wouldn't just die, you would be stretched into a single, thin line of atoms. It sounds like science fiction, but this is the brutal reality of physics when gravity reaches its absolute limit. Imagine you are floating toward a black hole, feet first. Because gravity gets stronger the closer you get, the pull on your feet becomes significantly more intense than the pull on your head. This difference is called a tidal force. As you fall, these forces begin to tug at your body with impossible strength. Your body undergoes a process scientists literally call spaghettification. Your bones, muscles, and even your blood are pulled apart, turning you into a long, thin stream of biological matter. At this point, the gravitational gradient is so steep that no material in the universe can withstand it. You aren't just being stretched, you are being dismantled at the molecular level. Your physical form ceases to exist, replaced by a trail of particles spiraling into the crushing darkness of the singularity. Click this video. Most people think all black holes are the same, but that is a dangerous misunderstanding of gravity's true power. Today, we are putting a stellar black hole against a supermassive titan to see how they truly stack up. Imagine a star 10 times larger than our Sun, dying in a violent explosion. It collapses into a stellar black hole, a dense, city-sized point of infinite gravity. It's lethal, sure, but it's a mere speck compared to what lurks in the hearts of galaxies. A supermassive black hole is millions, sometimes billions of times more massive. If you could somehow shrink the stellar version to the size of a marble, the supermassive one would be the size of our entire solar system. The real problem isn't just their size, it's the reach of their hunger. A stellar black hole is like a sniper, pulling in nearby dust. A supermassive black hole is an ocean, pulling in entire star systems as if they were nothing more than debris. When you compare them side by side, one is a dangerous trap, while the other is... Deep within the heart of every spiral galaxy lies a monster so heavy it bends the fabric of space itself. You might think stars just float through the void, but they are actually dancing around a hidden gravity trap. At the center sits a supermassive black hole, an object with the mass of millions or even billions of suns packed into a tiny space. It acts like a cosmic anchor. While it pulls everything toward it, the stars move fast enough to stay in a perfect, stable loop. But here's the real puzzle. If these giants are so hungry, why don't they eat every star in sight? However, if a star gets too close, the gravity becomes so intense that it stretches the star into a long, glowing strand of gas, eventually pulling. Black holes are famous for being the ultimate vacuum cleaners of the universe, consuming everything, even light itself. But what if I told you that black holes are actually leaking? At the very edge of a black hole, the event horizon, space is far from empty. It is a chaotic sea of virtual particles popping into existence, only to crash into each other and vanish in an instant. Occasionally, one particle falls into the abyss while its partner escapes into space. To an outside observer, it looks as though the black hole just shot out a particle. This process, known as Hawking radiation, creates a massive problem for the black hole. Over billions of years, this thief is slowly shrinking the most massive objects in the galaxy. If a black hole disappears, where does all? You might think that once something falls into a black hole, it stays there forever. But the truth is much stranger. Black holes are slowly committing suicide. Even the most massive objects in the universe have an expiration date. For decades, we believed that nothing, not even light, could escape a black hole's gravity. But in the 1970s, Stephen Hawking proved that black holes aren't actually black. They leak. This process, known as Hawking radiation, works because of the weird way quantum physics behaves at the edge of the void. Pairs of particles are constantly popping into existence near the event horizon. Usually, they cancel each other out, but sometimes one falls in while the other escapes into space. That escaping particle carries away a tiny sliver of the black hole's mass. It's like a massive ocean being drained one drop at a time. It takes trillions of years, but eventually the giant shrinks. As it loses mass, it gets hotter and glows brighter. In its final, frantic moments, the black hole explodes in a flash of pure energy, vanishing from existence entirely. If you want to, imagine a giant, invisible beast that has been swallowing stars for eons, finally gasping its last breath. What happens when a black hole, something we think of as eternal, runs out of fuel and disappears forever? For billions of years, a black hole leaks energy through something called Hawking radiation. It's a slow, steady drip, losing mass bit by bit. It shrinks, getting smaller and hotter as it struggles to hold on to its own gravity. It is the ultimate cosmic slow burn, taking longer than the current age of the universe to reach its end. But the end isn't peaceful. As it reaches its final second, the black hole becomes a ticking time bomb. It isn't just fading away, it is erupting. It dumps all its remaining mass into space in one final, blinding burst of pure energy. It's a spectacular light show that outshines the brightest stars, a violent farewell that marks the complete evaporation of an object that was once impossible to kill. The dark titan is gone, leaving nothing behind but a whisper of light in the. Imagine standing in a room where every single light bulb burns out, one by one, until only the shadows remain. This isn't a ghost story, it is the inevitable destiny of our universe. Trillions of years from now, the era of stars will come to a silent close. The fires that fueled galaxies will flicker out, leaving behind a cold, dark graveyard. In this infinite, frozen expanse, only one thing remains: the black hole. These gravitational giants, once the hungriest monsters in the cosmos, will drift through the absolute void, utterly alone. But even black holes cannot cheat the laws of physics. Through a process called Hawking radiation, these titans slowly lose their mass, leaking energy into the nothingness. It is a crawl toward extinction that takes so long our minds struggle to grasp the scale. They don't vanish in a flash. They evaporate, particle by particle, over eons that make the age of our current universe look like a single heartbeat. When the final black hole finally pops out of existence, the universe will be perfectly, terrifyingly. Imagine a universe where the last star has flickered out. We are left with nothing but shadows and one final, lonely traveler. Everything you know, the sun, the galaxies, the light, will eventually vanish. What remains is a cold, dark void. But in this emptiness, black holes are the last survivors. They don't just sit there, they slowly leak energy back into the nothingness through a process called Hawking radiation. It's like a giant cosmic battery slowly draining until there is absolutely nothing left to give. For trillions upon trillions of years, these titans hold the stage. But even they aren't immortal. As they shrink, they get hotter and brighter until, in one final, frantic burst, they pop out of existence. Once the last black hole evaporates, time itself loses its meaning. There is no heat, no motion, and no memory of what came before. It is the ultimate silence. We are looking at the final page of a book that took billions of years to write. When the last bit of energy drifts away, the universe becomes a graveyard.